Steam turbines. A steam turbine is a thermal prime mover that converts the heat energy stored in steam into mechanical energy in the form of rotation of shaft. The mechanical energy, in turn, can be used to drive other machines or devices. Prime mover any device, which is responsible for movement of an object machine, is called prime mover. These devices utilize the various sources of energy available in nature and convert them into useful mechanical work. The work thus obtained is used to drive other machines. Steam turbines are primarily used in thermal power plants to drive the generators or alternators which produce electricity. They are also used to drive propellers of ship and high-speed machines such as centrifugal pumps, centrifugal blowers, centrifugal compressors, etc. Power plant is the place where power or electricity is generated from a given source, heat, water, or gas. Thermal power plants convert heat energy into electrical energy. Working principle of steam turbine. Energy conversion in a steam turbine takes place in two stages. The heat energy in steam is first converted into kinetic energy in a nozzle or set of nozzles, and this kinetic energy in urn is converted into mechanical work with the help of curved blades. The details regarding the principal parts of the turbine are discussed briefly: nozzle, blades, and vans. Casing. Nozzles. A nozzle is a passage of varying cross-section through which steam flows. The aconvergent-divergent nozzle, in which the cross-sectional area of the nozzle diminishes from the entry to throat and thereafter diverges to the exit. Steam is expanded in a nozzle to increase its kinetic energy. Working of nozzle. The high pressure and low velocity steam generated in a boiler enters Thaler, and as it passes between the entry and the throat, the pressure of the steam drops to ATK value. In other words, steam expands to a low pressure. This drop in pressure reduces the enthalpy or heat content of steam. Since there is no external work and heat transfer in the nozzle, the reduction in the enthalpy of steam must therefore be equal to the increase in velocity, kinetic energy, of the steam. In other words, the steam performs work upon itself by accelerating itself to a high velocity. Hence, the steam comes out of the nozzle with low pressure and high velocity. Beyond the throat, the nozzle diverges to a certain length, so as to allow any incomplete expansion of the steam to take place. Next, blades or vanes. The blades of the turbine are made in the form of curved plates and are fixed on the circumference of a revolving wheel called rotor. The rotor, in turn, is connected to a shaft, which is free to rotate in a set of bearings. The high-velocity jet of steam coming from the nozzle is made to impinge, glide, on the blades. The impingement of steam on the blades rotates the rotor, which in turn rotates the shaft connected to it. Thus, the kinetic energy of steam isque into mechanical work. Casing. Casing is the outside cover of a steam turbine. Rotors are placed inside the casing.